Hello, one. So we have AMC 12A, number 25, and number 22 for 12A. So this was the interesting question. So we have a figure shows that like eight like great cells with the wide and three cells that's tall and consisting by one squares. Okay, so we have like 3 by 8s basically rectangle. And the person, Carl, placed 1 inch toothpicks along some of the sides. Okay, so we are gonna place some of the toothpicks along some of the sides of the square to create a closed loop. Okay, this is the, I guess, the most restriction so far. So we are gonna create a closed loop that does not intersect itself. Okay, so the number in the cells indicate the number of the sides that square that are covered by the toothpaste. Okay, so meaning that like for this square, we have one in the middle, which means one of the sides should have only the toothpicks. Okay, so not more than once. But for the other one, there is no number, so it could be any number. So for the one that we are given once, that we should have only one around that square. Okay, so and the number of toothpicks are allowed if no numbers is written, so which is very tall. And how many ways can Carl place these toothpicks? Okay, so this is kind of not really easy problem at first, but at the end you will see actually it's kind of simple. Even though this was number 25 and number 22. So the first thing is I would do just explore like until you see something. So the first thing is, you want to look at the restriction. So we want to like have only one, right? Because like there is no easy way to guess, like because there's too many ways to determine these squares, like for the top ones or the bottom ones, because there is no number, but in the middle ones, there's only ones, right? So maybe we can start with those because it has less like like I guess more restricted, which means like you have only like a few options that you can go with. For example, if I wanna, I don't know, like start with, let's say this one. If I wanna like have this is the toothpicks, right? Then this square right here cannot have anything other than this because this is already one. So I cannot have here, I cannot have here, I cannot have here either. So then I will just say, this is no good, this is no good, this is no good. But after that, since we are gonna find the closed loop, maybe we can extend above because otherwise we are stuck there. So we need to have this one for sure when this is the case, and the same reasoning, this has to be as well. Okay, this is something, but now, we can continue like doing this way because we need a closed figure. So that will make some picture like this. And now we have this one. We may go downward or we can go this way. The same thing with this guy. And then like whatever we did on this left side, we can start with this as well to make that a closed shape. Okay. And but the thing is, these are the ones that means we need at least one toothpicks around that squares. So since this is not okay, so we can have this one or we can have this one, but we cannot have this and this at the same time. We should have only one of these, right? Um, that's why maybe we can go downward from here, but we cannot go that like up that way because we cannot go this way when this is the case. So we have to go this way if this is the toothpicks we use. So which is actually telling us something now already because like for the middle squares, you can have either like the top one or the bottom one. So when you determine which one to choose, then the rest is kind of determined immediately. So this is, let's say, the one you choose, you cannot have this one, which means you should go this. And if you choose, let's say, this one, and then you cannot choose this one either. So like this is kind of experimental. So like in that case, if I want to complete this like set, so I should have something like this. And I need to continue with this because there's I can go this way, but if I want to complete that, so I should go that. But since these are chosen, I cannot go this way, so I should go all the way here and then connect with this to make it close. And since this is given, so we cannot have anything on this, so we should go up and then we continue that way and connect with that. So we cannot do this because that will make two on around this side. So we should go up again. And then for this one, so to make that close figures, I should go back because I cannot cross this because this was already there. So I can have something like this. And if I just continue in this, I'll get this. But for the last one, like there is a couple ways then. Like we can, like actually in this case, we may have like maybe this way and finish that way, right? So if I didn't choose this one, I should choose this one. But if I go that, right? So that means we may have such a thing. So far, like the middle ones are good, right? So, but this is one, so I can have something like this. Okay, so this is kind of good looking, but this is gonna tell us like a bit more as well. Like I said, as soon as you determine the left side, then or the right side, so you can see middle ones has not many options. So there is like one unique way to finish up when you determine the top and like bottom rows. So, but here's the thing, like we don't really need to go this way. Maybe we can do like something like this. Like I start with the corner right here, right? Maybe instead of doing that, so I can have, I don't know, like from maybe this one, because if I start with this, then I don't have to go this way. I don't have to go this way. If I go this way, then I will intersect with myself again at this corner. So I cannot have these ones, which means if I start this one, I should have these two for sure. Okay. And then I should go this way. But you know, I can start from here all the way to the right end, or I can start like end right here as well. So like, which basically telling us I can stop at this. So I can have everything between these two like rows. So then like the rest is just finishing up the remaining part. So I can have something like this, something like this. So if this is the case, you know, I can have the same thing from this as well. So I will go here and then I will go here. So now the rest is just the determining which one to choose, either like the top of the ones or the bottom of the ones. So like if I choose this one, for example, and then these two, and then maybe this one, so like I'm just choosing one of the top or bottom, which means every one middle one, like we have a square that has a one in it. We have two options, like either top or the bottom of those, because we have only one to pick. So when you determine, let's say these guys, so there is only one way to finish up. So since I need to close this one, so I need to connect this, and then I cannot cross this, so I should go this way, and then that will make this closed shape. And then from here, so I cannot touch here, so I should go all the way here and then connect with this. Since I cannot go this way, so I should go up and like do this way. But when I do this one, you see this middle guy is not there. So that's why I should probably clean that mess. So like I can have this one and this one, and then I can have such a thing. So this is okay because like, you know, actually we should have it this way. So I'll go with this. Oh no, I did not this one. Because this was given, so I should go all the way here. Okay, so I think that looks good. But this one doesn't look good, so maybe I should have maybe done this way, or I can go with that. So either way, that's what actually works. So let's finish up that way. So like if I if I go this, right, and then this, so I didn't choose this region, so I should be going something like this. So this is another like figure that we can have. Okay, so based on this, like we see there are a couple ways that we can achieve this, like meaning that we can start with, let me clear this. We can start with the corners like this one and this one, because whenever you have like this middle is like used, one of those like this used. So in order for us to move on to the left or right, there is no way, because if I go with this, it will be 2, not 1. So that's why we should go up and down. There is no way to finish up other than that. That's why if I start with the corner ones, I should have these 3, and then I should have these 3. Okay, so now as soon as we determine that, so we are gonna go this way. We are gonna go this way. That's something we have. And then the same thing with this. So we may start from all the way from corners. So that might be one way to start with. After that, like we can just determine one path. So I will just kind of continue choosing some of the tops and some of the bottoms. So based on what I did, I will make a closed figure. So let's say I choose these 2, and then these 3, and then this one. So like if these are my selection, then my figure should be like this. So I go down, and then I go down, I go that, and I'm done with that. So like if I wanna have this guy, so I should go all the way here and down, and then I should go down and connect that way. So when I do this way, as you see, this one is this one. This one is this one is that. So it looks like this is one of the good paths. So, but the thing is, if I put this backward, so like every selection I make after this one, like I can choose this one or this one, right? So I have 2 options for this. So let's keep that in mind. And the same thing with this. For this one or that one, I have 2 options for that. So this one or that one, or this one or that one. So we have 2 options for each one of these middle like squares are gonna have that 2 picks on the top or at the bottom. So that will be 2 to the 6th power for this case. Okay. So whenever you decide which one to choose, then there is only one unique way to finish up. So which is why we are gonna have, in this case, not both. So we have 2 to the 6 ways that we can do this. But the thing is, we have some other ones that we can actually do as well. Okay, so which is why I will say, let me copy this. Okay, so the second case, maybe I should add more. And one more, because I will have 3 more cases of this kind. So like, think about these 3 cases, right? So like, I can start with the corners, I get it, but here's the thing, like we may start from the corner, and maybe we stop at this point instead of like finish all the way to the right. So in that case, like we start with the same way, like these ways, okay? And then we can just decide how many ways can we finish. Like we have 1, like this is 1, 2. I have 2 choices. I have 1, 2 choices, 1, 2 choices, 1, 2 choices, 1, 2 choices. So we have, like in this case, 4 options instead of 6 options. So you can choose either top or bottom. So you got 2 to the 4th power. And similarly, if I start with the corner again, but maybe not this corner, so maybe I can start with this corner, right? And then maybe finish up 1 before from the left one. So this is the same as this one. It's, the only thing is we are starting the right side, but we are finishing 1 before the left. Okay, so that is gonna give us 2 to the 4th as well, because that's the same thing, okay, as this one. And the last case, like I said, we can start with all the way from corners, all the way from the right corners or left corners, or we can skip 1. And maybe we can do this skipping 1 from each corner. So if I do it this way, Okay, so 1, 2, 3. Actually, this was 5. And this is 5. So in this case, we have 1, 2, 3, 4 top or 4 bottom. So which means I'm going to choose one of these 4s, which is going to be 2 to the 4. So like if you combine all these together, but make sure you really like kind of convince yourself why this is only one unique way when you determine the top and bottom. So after that you just add them. But the thing is, if I add those numbers, I got like 64 and 32, 32, and 16. So that's 164, another 61, 28, 144. So if I go with this, as you see, one of the choices is 144, but there is another choice that's really close. So which is why I feel like this is one of the question that they have some other like ways that we can do, which is why you don't really want to just dive into that immediately, especially this is a question that you really get a lot of stuff and you don't want to miss. So the other 2 points actually, I mean 2 ways that you can get the close figure is using the top and bottom row. Because if you do this, for example, like this is also okay because I don't have to use the entire figure, so I can use the top one. When I have this one, all these like ones are covered by the toothpicks, which is why these are ones. So I can just complete these numbers. And then this is not special. I can do it at the bottom as well. So that means there is 2 more, which will give us the choice C. So again, this was interesting question, but make sure you like take a look at each step and convince yourself why that's gonna be the case, because otherwise there is no way to get a close figure or like without really intersecting the corner. So that was the number 25. Anyway, I hope that was clear. I'll see you in the next video.